Welcome to This Explainer. Okay, let's just jump right into it. Today we're demystifying the extreme complexities of modern data centers using Supermicro's latest white paper on their SuperCloud Composer architectural framework. If you've been tracking the massive shift in enterprise and AI compute lately, you already know that keeping these facilities running is no longer just about plugging in servers and hoping for the best. It requires an entirely new level of orchestration. To kick things off, we really have to ask a pretty provocative question. How do you actually manage a data center when the servers run hot enough to literally boil water? I know, it sounds like hyperbole, right? But it perfectly captures the high-stakes, intense thermal realities of today's AI compute environments. We are dealing with unprecedented power consumption and thermal density, turning what used to be predictable operational inputs into highly variable, workload-dependent challenges. Here's our roadmap for today. We'll look at the data center dilemma, introduce SuperCloud Composer, and then dive into managing AI superclusters, compute and network orchestration, mastering power and cooling, before finally harmonizing future infrastructure. Let's get to it. Starting with Section 1, the data center dilemma, focusing on the sheer heat and cost of modern AI. So the reality is that the physical and financial pressures of scaling AI are just flat out breaking traditional operational models. As CPU and GPU thermal design power, or TDP, continues to surge, overall power usage effectiveness is taking a huge hit. Physical footprints are expanding, operational costs are climbing, and facilities are being forced to make a massive shift from legacy air-cooled systems to liquid-cooled environments. But here's the kicker. IT leaders are still trying to manage these complex liquid-cooled setups with fragmented legacy tools. And honestly, those tools just weren't built for this era. Which brings us right to Section 2. Enter SuperCloud Composer and how it harmonizes your infrastructure. This is where we meet the ultimate conductor for this wild hardware orchestra. Now, we throw around the phrase single pane of glass a lot in IT, don't we? But let's define what a true single pane actually means in this context. According to the white paper, it is a unified architectural framework providing a single source of truth, real-time telemetry, and operational control across all infrastructure. Essentially, it replaces dozens of siloed tools with just one centralized control plane, managing multiple generations of tech simultaneously. In the real world, this gateway is the core interface, managing everything, from standard compute nodes all the way to highly specialized liquid cooling systems. By bringing system health, power consumption, and cooling behavior into one single unified view, operators can finally make sense of and optimize their environments in real time. If we break down the day 0 to day 2 lifecycle into these 4 steps, you can see exactly how SCC automates the vital stuff. It monitors alerts and power utilization. It manages provisioning. It pushes secure updates for BIOS and BMC firmware. And it maintains the fleet for capacity growth. It essentially takes all the heavy lifting out of managing a mixed compute fleet, making sure everything plays by a single set of compliance rules. Moving into Section 3, managing AI superclusters and controlling high-density GPUs. Okay, so how do we actually tame the real beasts of the modern data center? Well, the beauty of a unified architecture is its pure scalability. Whether you are orchestrating a massive hyperscale cloud facility, a traditional enterprise setup, or even a remote edge deployment, this platform scales perfectly to meet the need. It keeps firmware consistent, monitors health, and maintains cooling awareness, no matter the geographic location or the size of the deployment. When we're talking about AI superclusters, we're talking about operations purpose-built for massive GPU deployments. SCC gives you unified control over the compute nodes, the NVLink fabric, and the cooling systems, all in a single operational view per cluster. Think about that, managing thousands of GPUs as one single system. You get deep, granular in-band telemetry into thermal output and PCIe throughput using Prometheus exporters, seamlessly tying into vendor-specific metrics like NVIDIA's DCGM, AMD's ROCm, and Intel's One API. Next up is Section 4, Compute and Network Orchestration, focusing on automated provisioning and compliance. Because beyond just monitoring performance, a good conductor actually has to direct the instruments. You cannot manually configure thousands of switch ports and expect to stay sane. SCC handles the day-to-day grind with zero-touch, image-based bare metal OS provisioning. It automates network switch setups using JSON configs, and this is probably the most impressive part. It uses an intelligent agent called Switch Sweeper. This agent actively validates your live switch configurations against your intended build plans to enforce strict compliance. Whether it's rolling out operating systems or configuring storage fabrics, SCC handles all that heavy lifting, either sequentially or totally in parallel. To actually manage all this visually, the platform offers a topology view, which is basically an instant graphical map of physical connectivity between your servers and your management, compute, and storage switches. You can instantly spot broken links, warnings, or powered-off hosts. It maps out exactly how your entire infrastructure is wired together across all your racks and drawers. That brings us to Section 5, Mastering Power and Cooling, specifically the massive shift to liquid cooling. Now we've reached the highest stakes area of modern infrastructure, managing the intense power constraints and critical cooling demands of next-gen hardware. When you contrast traditional air cooling with the new liquid-cooled reality, the white paper makes it super clear why real-time telemetry is absolutely non-negotiable. Air cooling's just getting way too inefficient and costly at these high power densities. Modern liquid cooling is foundational for GPUs, sure, but it brings in complex new components. We're talking active CDU monitoring and a massive need for strict telemetry covering pressure, flow rate, and leak detection. So SuperCloud Composer steps in as the central brain for all of this cooling gear. It monitors in-rack and in-row coolant distribution units, or CDUs. It tracks sidecar liquid-to-air heat rejection, rear-door heat exchangers, and even hooks into facility-level cooling towers. Plus, it maps power all the way down to the specific PDU outlet. That gives you incredibly granular energy analytics, so you know exactly where your power is going, and more importantly, how effectively it's being cooled. But look, this isn't just about efficiency, it's about avoiding disaster. When you are running water right next to highly sensitive, incredibly expensive electronics, safety is absolutely everything. SEC uses policy-driven leak detection to enforce automated protection actions. Literally, the exact microsecond a leak is detected, the system coordinates immediate safety responses and emergency stop mechanisms. It's essentially an active safety net for your most critical assets. Finally, we arrive at Section 6, Harmonizing Future Infrastructure, Building the Integrated System. Bringing this all together really demands a fundamental shift in how IT leadership views the modern data center. This quote from the white paper absolutely nails our core takeaway today. Supermicro's approach is centered on ensuring that the data center operates as an integrated, efficient system, rather than a collection of isolated components. You simply aren't going to survive the AI compute era with a bunch of fragmented tools. You need a unified system playing in perfect harmony, from the top-of-the-rack switch fabric all the way down to the coolant flow rate. I want to leave you with this final thought to chew on. Look at your current dashboards, your management tools, your operational workflows right now, and ask yourself, is your data center truly equipped with the single pane of glass needed to orchestrate the AI era? Are you really ready to manage the heat of tomorrow's infrastructure? Thanks so much for joining me on this explainer, and keep learning.